We are now going to take a look at a few points regarding this course, looking at the course intro. For this course, you can be really either brand new to Java coming from another language or brand new to programming overall. I'm going to go pretty slow, and fundamentals will be covered in detail, so you're going to be good either way. I'm purely focusing on the language in this course, not looking at manual compilation, platform system stuff, not looking at any of the Java tools, the Java ecosystem, purely on the language. Language is difficult enough to grasp, so I'm staying there. I'm going to utilize onlinegdb.com, a web browser-based IDE, to get away from local installation and going through that process with you and talking about, Mac OS, Windows, blah, blah, blah. Just go to the web browser, put in this, and again, focus on the language. Of course, it's going to be composed of slides and code demonstrations. Slides to really lecture the concepts, code demos to illustrate the concepts. Going to kind of go back and forth. You're going to see a lot of code in this. I want to take a few minutes here to introduce you to the world of programming and some ideas using an FAQ as the format. Check it out. I think this is a good way to learn about really the basic ideas behind programming. So what is programming/coding? First of all, programming and coding are the same thing. Coding is kind of the new word. When I came up, we were called programmers. The word coding wasn't really used, but it is what it is. I'm old school a little bit. But what is it? Whatever the name you give it, what is it? Really, it's the creation of instructions in code for a computer to execute. The programmer composes what is called source code, and it's this kind of it's kind of part English, part symbols, and it's arranged in kind of a weird way if you don't, if you haven't been introduced to code. But this is kind of like coded language. The computer can understand it. You feed it in there. It's a set of instructions to really tell your computer what to do. And when you package these instructions and store them, that's really what software is. Like when you install some software in your system and you double click it and run it, those are pre-made instructions that are running. And when you run the program and you use it, someone else, or usually a team of people, has coded the instructions in, and the computer is just doing what it's been told in that software package. But yeah, storing those instructions is the software. That's what software is, very simply. What is the basic process programming? Like, in a very general sense, what are the steps to go from nothing to something? The first part is source code, where this is the code I was just talking about. Combination of letters and symbols, organized in such a way that the computer can understand it. The programmer composes this code and feeds it into the computer, and it's going to be in a text format file. But that's where it starts. And then it goes to this middle process called compilation or interpretation. Depending on the language that you're using, the programming language you're using, it determines if it's compilation or interpretation. But in this step, the source code created by the programmer is transformed or metamorphosized, as it were. I don't even know if there's a word. It is changed into runnable code. But this intermediary process is called compilation or interpretation. I use a mixing bowl here because it's kind of like you're taking the code, changing it up, and you're adding some things to it too, usually, if you're creating a real application. So it's kind of a combining, mixing, and transforming process. And then you're left with the output. And the output is a runnable program. And here I'm using an exe icon because in Windows, the Windows operating system, most runnable programs will have a .exe extension for the file, meaning that if you click on that thing, it's going to run, it's going to execute some instructions. But the runnable program is the output of software. So yeah, it starts over here as text, gets transformed, and the output is going to be a runnable program. So you as a new programmer, your desired outcome when you code is to create software, create applications to create runnable code. What do you use to do coding? You may have this question if you've just never even gotten into the idea, like, what do you actually use to do this stuff? I always see people pecking away. What are they typing into? Well, there's a certain kind of application that's pretty prevalent these days called an IDE. An IDE, which is an integrated development environment, is typically used to compose code. It's an application that contains most of the elements necessary to produce software. It's a multi-part application where it's got an editor, it's got a compiler or interpreter, it's got a debugger. Sometimes it has a graphical editor if you want to do graphics in your code. It's got sometimes it's got documentation in it. It's got a lot of stuff where it's almost a one-stop shop type of program where you can go in there and be able to produce almost any kind of software that you want. It's almost a self-contained solution, and they're usually language specific. Like there are certain ones for Python, certain ones for Java, certain ones for C++. There are IDEs that are multi-language, but it is more common to have them per language. I'll show you real quick what an IDE looks like here. This is an IDE called PyCharm, where you got your code editor, you got your output area in the bottom, and there's a lot to this program. You got like a folder tree over here on the left that for some reason I can't expand it right now, so I'm not going to bother. But that's what an IDE looks like, and you see the source code right there. This is source code. So the question is, like, how does this shit all work together? Like, okay, you told me what the code is, or what programming is. I kind of see the general steps, but like in a workflow format, how the heck does this work? Let me take you kind of from start to finish, where the programmer is inspired to do something, and then like what are the general steps toward getting that thing done, like from point A to point Z, so to speak. Starts a programmer getting an idea, getting inspiration, just like an artist, or like a musician, an artist, or a producer of some sort, who like a writer who creates something. They get an idea. I want to do this thing. I want to write an application that does X, Y, Z. I'm going to sell it to these people, blah, blah, blah. I'm going to make millions of dollars. I'm going to be dope. I'm going to get the girl. Totally awesome. So you get an idea. And then the next step, of course, you got to bring that idea into practicality. You've got to research and plan out a strategy to get it done. Like, now that I've got this idea, ideas are plentiful, but like, how do you actually go about getting it done? So the programmer researches technically how to get it done. So I've got this app that I want to, create. What is it going to take technically? What language am I going to use? What pieces of the language am I going to use? What libraries do I need to import? What do I need to learn to be able to do this thing? Because a lot of times when you're taking on a new project, you've got to learn something to be able to do the project, not just using your own knowledge that you already got. And then the coding begins. You're going to write code, but you're just not going to write the whole thing in a just one fell swoop. The correct way to code is to be modular, is to break the project down into sections and work on section at a time, and really Make that section tight, then move on to the next section. Write your code in modules, basically, like, one part that queries the database, one part to do the graphics, one part to print error messages, and then what you do is you bring all these together. That's a good way to do it. So it's kind of like in real life. When you've got a big problem, you break it down into pieces, look at the pieces, figure them out, and then bring them back together. And that's what you do with coding. Because the next step is you bring all those sections that you made nice and got them all tight, put them together and get them to work as a whole. I use a picture of Voltron here. Some of you older cats may know what Voltron is. It's a toy that's formed from 5 other individual toys. So it's like this big robot that comes together from, I think it's 4 or 5 smaller robots. There was a cartoon and a toy back in the 80s and 70s, so I think it was the 80s. But yeah, Voltron. Think of the idea of Voltron, because you're going to be bringing your sections of code together, now working as a whole. It's a beast, right? Once you got all your stuff together and it's working good, you go through this process of testing and refinement and debugging. Like, you got to make it nice and shiny, like this homie right here. Like, you got your stuff tight, make it shiny, test it again, security testing, like all this stuff's got to go in. And really these days, programming or applications are so complex that they've got entire testing departments, like people who all they do is test code and test software. So that's it. And once you've got a refined product, then you bring it to your audience, whether it's just you that's going to be using it, or you're going to sell this thing, or you're going to put it on Facebook to blah, 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 or to, I don't know, give it away. Whatever you're going to do with it, time to distribute. And then the process kind of begins again, where you go out there, people report bugs, and then you go back and fix them, refining again, putting it out there again. Software is never really dead. Like, it's always in maintenance, basically. It's never really a finished product, but you got to give it away at some point, and then you got to take it back, change it, and give it away again. I think you guys know what I'm talking about if you got a cell phone or a laptop these days. Anyway, here's a little intro to programming. Checking out the Java Foundations overview. Going to kick things off with the variables and data types, where you usually start, and looking at first just definition-wise, basically, variables and data types, and also looking at the difference between objects and primitive types. Very important thing in Java. We will look at input-output, looking at the main output function, system out println, and then looking at the main input class, the scanner class. Then we slide into operators. These are the manipulators of data, and the different types. Arithmetic operators, or arithmetic if you will, assignment operators, looking at also logical operators and or not, and then looking at the comparison operators. Also going to look at unary operators, not shown here. Then we get into conditionals, making decisions in your code, separate branches of execution, if, else, if, and else, and looking at switch, which is kind of an alternative for certain situations for if and else if. Then we look at the automation loops, looking at the different kinds of loops, the for loop, the while loop, the less used do while loop, and also looking at the enhanced for loop, which is kind of a for each loop in Java. Then we look at the array type. This is a foundational data structure in a lot of languages. Basic syntax, creation, initialization, indexing, super important concept in programming, and some array operations and looping through arrays. Very often used. The way you represent text, looking at the string class, creation and the properties of the string class. Character access, accessing individual characters and combining through concatenation. and we look at string class methods. Looking at object-oriented programming basics. OOP is intertwined in Java to the core, so we gotta cover it. Looking at concepts, looking at creating your own classes, and then looking at object uses once you've created the classes. We slide into collections, looking at collections framework, Java data structures, concepts of the framework, and looking specifically at certain classes, looking at the array list and hash maps. Then finally, we get into methods. These are Java functions, basically. Looking at the functions or the structure of the methods, creating your own methods, and then also accessing methods from objects. Then finally, we get into the Java class library. These are classes that you can import into your code so that you don't have to create the code yourself, read the documentation, and looking at commonly used packages and classes. And that is the overview. Welcome in now to the actual course content. Now that we've gotten through the introductory material, I'm sure you liked it. It was necessary for some people, but now we get into the real dang course. Let's go. Variables and data types, let's get it. Yep, I just said it. So we're going to define a variable first. For those of you new to programming, for those of you who are not new to programming, you can kind of fast forward a little bit, it's all right. But for those newbies, a variable is a storage container in a computer's memory to hold data. You create this spot in memory, you place usually a single item of data into it, and you supply a name to that location so that you can refer back to it. A variable can be likened to a cell in a spreadsheet with a name. And I typically will draw a grid like I'm doing right now. So I'm going to show you what I typically do to teach this idea. I know a lot of other dudes do it too, a lot of other individuals, but it is what it is. Maybe they do it because it's the best way to do it, right? Okay. So here you have like a spreadsheet type of thing, and you can visualize memory in your computer as this, because really it's like this set of slots where you can put stuff in and of course retrieve stuff. It's really easy to think of it as a spreadsheet. So here, let's throw some data in these cells, just randomly, semi-random. So I got 3 cells with 3 different numbers in there. And how you use variables is you're going to assign names to these cells, like maybe this one is X, and this one is Z, and this one is, I don't want to type out any words, so I'm going to use single letters. But all these variable names refer to the storage location. Of course, variables need names because if you place the data in there and then you have no name for the location, how do you get back to it? So it's almost like an address. And in coding, again, for you newbies, a variable name is typically declared like this, where it's X equals 25. And what this means is that the 25 is stored in a location named X. Of course, you'll see this soon, very soon in the course. So why do you use variables? Variables allow for storage and manipulation of data, as well as tracking changes to that data throughout the program. So you slap something in a variable, and then you do stuff to it. Maybe you run a function on it, you use it in a formula, and then you see what the value is afterwards. Like you put X into this equation or actually formula, and then you check the value of X afterward to see what the formula did to your variable. That's a very simple usage, but that idea is really why you have variables in programming. And variables are labeled with names for identification called variable names. Very appropriate, right? A variable name is called a variable name. Captain Obvious, right? Here's a graphical view of the graphical view that I just gave you. I don't know why I'm doing it twice, but hey, let the knowledge sink in. You got rectangles here, and these can be, memory locations, and you've got data in the memory locations. And then you've got the variable names pointing to those locations. This is how variables kind of sort of work. Although I'm sure the real implementation is a little different, but we can think under the hood like this. Now let's define data types, now that we've defined variables. Data types are categories of data, classifications, like types of data. Very smart, right? Data types are for identification and defining what operations can be performed on data. So the reason you have data types, the best reason I can think of is that they define operations that can be performed on the data. Like think of numeric data versus text data. There are different operations that can be performed on each of them. And you need to define what they are so that you can say, with a number, I can add, subtract, multiply, divide. With text, I can read it, I can reverse it, I can split it, I can I was going to say something funny, but I'm going to restrain myself. I can put pieces of text together, but they define operations that can be done on the data, and I'll just stop there. So don't want to go down a weird route. Variables are often referred to by the type of data that they contain, like integer variable, which is a numeric type, or string variable, which is a text type. So yeah, variables are defined by the data that they contain, and that's how programmers typically talk about variables. Oh, this is a string variable, this is an integer variable, as they read code and talk about it. Yeah. Oh, I thought there was no bullet there, but there ain't. On to the next one. What you got here at the top is you've got two variables being declared and initialized. And this is actual workable Java code. Of course, it's not a full runnable program, but it's these two snippets. If you put them into a real Java program, they're going to work. So here's just a quick look at how you create variables. You have the data type first, the variable name second, equal sign to make it equal to something, and then what it's being equal to. The value, the values at the end. Then you have a semicolon. Most lines in Java will end with a semicolon. And identification purposes, these variables are kind of defined by the type that is in front. New var is an integer variable. Newer var is a string variable. And notice the data that is going into each, obviously text data, numeric data. Yes. We will now check out a few basic Java data types. And this is not a comprehensive list of data types, of course, just these are the ones that we're going to be using initially in the course. So I'm going over these first. And those of you who are not new to programming, but new to Java, you can kind of tune in now because we're going to have some Java specific information. This is really where that stuff starts. First data type is the integer. Most programming languages have integers as a data type because it's a very basic kind of, you really need integers to program. It's very integral, as it were, using that term. An integer is a whole number. It can be positive, negative, or 0, just like your algebra integer. And here is how you would create an integer in Java. And the syntax here, and for those of you who don't know what syntax means the rules that govern how to compose code in a language. The syntax here for variable creation is data type, variable name equals value. That's the syntax for initializing a variable in Java. Semicolon at the end. I may have gone over this already. I don't remember. I'm recording these modules out of order. So in case I repeat myself, you're just getting extra instruction, right? It's all good. Double and float. These are two decimal types. Decimal meaning a number with a decimal point in it. It's got to be a single decimal point. You don't see numbers with more than one. So there's two decimal types in Java, and the question is, why do you need two decimal types? What is the difference? Well, the difference is in the second sentence. The doubles are more precise, and they take up more storage than a float. You may ask, what does precise mean? What does more precise mean? Here is an example. We'll look at the classically used decimal number of pi. Most people know that pi, an approximation of pi is 3.14, a very not approximate approximation. When I say that, I mean there's not enough. Pi is a number that has an infinite number of numbers after the decimal point. And this approximation, it only has two numbers after the decimal point. So it is not that precise as to the real value of pi, because the numbers go on infinitely. If I added more numbers, like if I did 159, I've added a few more numbers of pi, and I've gotten it closer to that infinite number. I'm never going to, of course, be able to list them all out because it's infinite. But what I've done is I've gotten more precise. Adding more numbers after the decimal point has gotten me more precise to what the value of pi is. And that's the difference between doubles and floats. Doubles allow for more numbers after the decimal point, thus being more precise. Floats, they allow for less storage, so you can have less numbers after the decimal point. It's sort of an unspoken standard that doubles are going to be used more than floats in code. So in the code example you see with me, you're going to see doubles, and a lot of the stuff you see out there on the internet or at AI, which is of course on the internet as well, it's going to use doubles in their examples. So you see floats less. And here's how you would create a double variable in Java. We're still in Java, right? Yeah. Now I'm going to go over two text data types, the data type character and string. Character, it is a single text symbol. It's got to be enclosed. The data or the value must be enclosed in single quotes. And here's how the creation of a character would look in, or does look in Java. And with the single quote, I'm talking about the value size. So when you represent a value that is of a character, it is a single character in single quotes. So you can kind of tie those two together. Single symbol, single quotes. I say that because if you use double quotes, it becomes a different data type. If you use double quotes, it actually becomes a string, and you can't put a string into a character anyway, so it's not gonna work. Also, it's got to be only a single text symbol. If I put another X here and then another X, it would be triple X and it would be banned. But anyway, if I put more than one X here, it is going to not be a character, and it's not going to run. If I had 3 X's in a set of quotes, it will not run because it only allows for a single character. Character data type is kind of antiquated. It's kind of grandfathered in from older programming where characters were the only text data type, like going back to the C language in the 70s. Obviously, C is still used now, but it was born in the 70s. But in that language, character was the only text data type, and strings were kind of a hack where you created an array of characters to get a string, and you just don't see the use of characters needed in modern programming, at least in the stuff that I'm exposed to. But it's still here for kind of, maybe the word is posterity. I don't even know if that's the word, but I've heard that. Anyway, getting on to the next data type, it's string, and this is a modern data type. Whatever. A string is a string of text consisting of one or more text symbols. And a string must be enclosed in double quotes, meaning the data value must be enclosed in double quotes. So like character, the value must be enclosed in single. A string, value must be enclosed in the double quotes. Hopefully the mouse clicking ain't too loud. So we have string x equals hello world. So look at the right side, the value side, where hello world is enclosed in double quotes, and it's got to be double quotes. String, the value can be one or more characters. So I can have an H by itself. I can have hello. I can have hello world. You can have strings that are as long as 2 pages and put them in a variable. So I don't know that there is a limit to the size of a string other than maybe the size of the memory on your computer, which would be a very large string. Another thing to note is that strings, the data type name has a capital letter to begin. The ones you've seen so far have lowercase letters. String starts with uppercase letter because it's different from the other ones in that it is an object type, not a primitive, and we're going to get into that in a slide coming up. But a string is a different category of a data type than your character, integer, double. And that silence says we're moving on. Boolean. Boolean is a data type that only has true or false as possible values. Boolean harkens back to Boolean algebra, started by George Boole in the 19th century, British mathematician. Boolean algebra really forms the basis for computer science, electrical engineering, circuit design, pieces of philosophy, a lot of stuff. It involves logic tests that whose outcomes are true or false, and it involves the operations of and, or, and not. And we're going to get more into that stuff as we get along in the course, of course. But data type wise, Booleans are tied to only true and false values. Here's how you create a Boolean in Java. And you see the false there. It's only true or false in all lowercase and never enclosed in quotes. If you enclose it in quotes, it's a string it's a string and you can't put it in a Boolean and it fails. So you would usually use these to store the outcomes of logic tests. And you'll see them used, of course, later on. Moving on to the array. An array is a basic data structure. A data structure is really a collection of individual items or entities. And an array is a collection of items of the same data type that has a fixed size. Think of an array as a physical box where you can place a certain number of data items into, and they're there for, I guess you could say, more efficient usage, where you can group related data items of the same type, and you can run them through operations together. So it creates efficiency, among other things. But know that it is a collection, whereas these other data types are single entities. An array is a grouping of data items. Here's how you create an array in Java, where all the items in an array are going to be of the same data type. So you specify that data type. Where here, this is an array of integers, so it's going to be int. And then the brackets, the square brackets, specify that this is an array. The brackets are kind of what says array. So you can read this as integer array. And then X is the variable name. And this is the initialization syntax for an array. You have this new keyword. What the new keyword does is it reserves memory for the array, and you'll see new used in the creation of objects later on as well. But it really is a keyword that reserves memory, and it's going to reserve memory for an integer array, and this 5 is the size of the array. Sound like an old man up here. It's still morning. The size is the number of items in the array. And the number of items in an array is fixed, meaning it cannot change. So you set the size when you create the array, and it cannot change. There will only ever be 5 items in this array. I cannot add or remove from it. We're going to do an entire unit on arrays coming up, so you'll be well acquainted with arrays in Java. All right, those are the basic data types. And moving on to the next point, declaring variables. Variables must be declared before they are used. Kind of makes sense. You got to create it before you can use it. They must be declared with a data type and a variable name. Variables can be declared with or without an initial value. What's here is, this here is declaration only. So it's just saying this is a variable, but not giving it a value. Down here is declaring a variable and initializing the variable. So this is really a two-part operation. This is declaration and initialization, whereas up here is only declaration. The point of this slide is that you can either only declare a variable, or you can declare and initialize a variable at the same time in Java. But you gotta at least declare it before it's used. And many times you should give it an initial value before it's used, but that kind of depends on situations. Here I want to get into a Java-specific point about classification of data types. You saw data types, and we've gone over so far the specific data types, but there are classifications of data types in Java that are different than some other languages. So I'm going to hop into it right now. In Java, there's 2 major classifications of data types: the object type and the primitive type data. Primitive types are basic data types that contain only the value and whose names are always composed of only lowercase letters. Examples would be int, char, boolean, double, etc. And all the data types you've seen so far, other than string, are primitive. Primitives contain the value only, like an integer x equals 5. All it is that 5, and that's it. So by name or by nature, primitive, only containing the value. And right here, right now, doesn't mean much to you because you haven't been introduced to the other kind of data type, which is the object type, which is a more fully featured, I guess you could say, variable type or data type. Object types are multifaceted data types that can contain methods and properties as well as values. So object types are getting into the arena, or actually they are in the arena of object-oriented programming. And object-oriented programming is intertwined with Java at the root. So you can't really talk about Java without talking about object-oriented programming. Objects are, as it is said here, multifaceted, where they don't just contain the value, they contain methods, which are functions, which are things you can do, functionalities you can run on a variable, and they contain properties, which are descriptions of the data. So they contain methods can be called behaviors, and properties can be called descriptions. And this is a very abstract and kind of like out there concept if you've never been introduced to it. We're going to go over object-oriented programming, of course, in its own module later on. But object types they don't just contain the value, they contain a bunch of other stuff with them that enhance your ability to use the variable, like behaviors and description. And they're not going to mean this isn't going to mean anything until we get later on. But a simple identification thing in this last sentence that you can apply to object types is that object type names always begin with uppercase letters, like string, scanner, array list, hash map. Notice these all begin with uppercase letters. This is how you can differentiate object type from primitive type. We're going to go over all of these object types in the course and probably a couple of more, but the capitalization is a simple way to differentiate, but it goes a lot further, of course, where object types are these big kind of fully featured data types, and it'll mean something when we get further along in the course.